Hey everyone, welcome to the first lecture of our ISTA 321 data mining class. So we will be doing this at times. Sorry, I'm just making sure I'm recording. I've already gone through this once and realized I didn't screen capture. Anyway, we'll be doing some lectures like this to where it's just a more formal presentation, and I'll kind of talk through it. I'll also, of course, be posting the slides for you guys to go and work through as well. But so this one is just sort of an introduction to the idea of what is data mining, because some of you might not know. You probably had a stats class, you might have taken my intro data science class, but you might not have a understanding sort of the goals and some of the methods used, and how this is done and why it's important. So this is just a brief overview. So the first thing I want to talk about is that there's lots of definitions out there. If you start Googling what is data mining, you start seeing a lot of different things. I think because sometimes it gets muddled with machine learning. And so I think in terms of a definition, you can kind of say that it generally focuses on, extracting previously unknown information from sort of large databases. And so this differs from machine learning, that machine learning tends to be much more focused on kind of actively updating itself and actively learning from data being put in, right? So Google Maps is a really good example of machine learning being applied, where you input your route that you want to take, and it's constantly gathering information about the amount of traffic that's in there, any accidents, things that are reported, so on and so forth, and then it's updating your trip time accordingly, and it'll also then get better over sort of time, days, weeks, months. It's more data about, say, traffic patterns in the area, right? Where data mining tends to be, I don't want to say past looking, but it tends to be focused much more on say an explicit question. So you have some database and they want to know aspects about consumer habits, or if you buy one thing, who else you do buy another thing. So you have a large database and pulling information out of it that you can use. And so lots of times, the data is stored out here. You can think in terms of say a grocery store database, where you might have one database that's purchases. So you have some customer ID. So here's the same customer showing up twice. So they bought a couple things, M&M's, Red Bull. And then obviously it's different from customer, number 2 down here, who is coming late at night, buying a bunch of diapers, and 2 of them, pretty expensive ones, or I think it's expensive for diapers. And they're paying with a credit card and using coupons. As you can imagine, sort of different marketing techniques that an individual might use or a company might use based on this. And of course, then there's normally multiple databases. So then they'll probably also have a database on customer ID and their demographic information. So our one who's buying Red Bull and M&M's is younger, is married but has no kids, and income on the lower end, compared to our person here who is a little older, single parent, and has 2 kids but has a substantial income, and lives in a different area. So you can imagine sort of if you start seeing trends and patterns either among these different groups, among people who purchase different things, these different zip codes, that you might adjust aspects of inventory or stock or sales or ads or whatever it is accordingly. So you can obviously use these data to understand your customers and sell them and ultimately then make more money. So why is data mining important? I think it's important to kind of step back and be well, how did we get data before? How did companies and industry and whatever it may be actually get this information before? What information they have to work with? And it used to just be a lot harder, right? So if you had a new product, or you wanted to get an aspect of what an individual preferred, you would a lot of times have to do things like focus groups or surveys, or go out and actually ask people directly. Which are obviously very expensive, it's very time consuming, and it requires a lot of manpower. So it's fundamentally, you're really limited in terms of how much information you can actually get. Sales in a store, I worked in a bicycle store that did not have a computerized inventory system. So once a year you had to go through and count how many tires of each different brand, how many bicycle cables, whatever it is you want to consider, and physically inventory every item. And that's lots of times that can only be done on a yearly scale. So it was much harder to actually then track, well, what were our sales in our different item categories? Are we buying the appropriate amount of, say, clothing versus new replacement bike tires? And so obviously very difficult before sort of automation and the computer systems existed and were broadly prevalent. Stock market, so you go way back when, it's probably paper spreadsheets, or lower scale resolution in an actual database. Stock market has been sort of up on the trends in terms of always leveraging computational power to sort of forecast what different stock prices will be, but still we now have a lot more resolution, a lot more detail compared to before. Political opinion, right? So again, you need focus groups or surveys or polling or county records. So you would have to go and get all this information, all these different ways, and mix it together to sort of give an aspect of, well, what do the constituents in an area like? How are they going to vote? Where should we be putting our money? Which is obviously very different now, where Facebook is a massive venue for politics, to where you can get a lot of information and advertise accordingly. Climate data, so sensors used to be much lower resolution. You would get, say, 1 read a second or 1 read a minute or whatever it is, and nowadays, obviously, they're virtually recording continuously. And so, but the point is like these are all really small in terms of detail. They're really limited, and they're limited kind of in 2 ways. So they're low resolution, so you'll probably only have a few people respond if you start thinking about whatever survey it is. You might send out 100, and you would maybe hope to get 10 responses back. And they're really shallow in terms of depth, so you can't get deep into a topic, just given it's going to reduce the likelihood of an individual walking away if you're talking to them in person. Or not even submitting it in, so submitting the survey in the first place. And so you're then just very limited. So, you might only have age, or number of kids, or if they're married, and maybe a few other questions. And you couldn't get more detail that obviously a lot of different people would want about specific questions or demographic aspects. And so the idea is that, historically, you could get insight from simple methods when data is really sparse, but data is very not. You're limited in the questions that you can answer when data is sparse, and you're limited in the depth of insight that you can get. And so, like, nowadays, like, clearly data isn't sparse, right? So when you think about sort of the explosion of data, you can see that there's sort of this exponential trend of just billions and billions and billions of gigabytes, exabytes, and will continue to explode. And so now we don't have this depth or resolution problem that we used to have. And it's not just a single type of data too, right? So all these different companies are producing all these different types of data. It's not just purchase data. It's, the number of Snapchat shares, or how many LinkedIn individuals like create a profile. Google's conducting 3 million searches a minute, or almost 4 million searches a minute. And so each one of these searches is a single line in the database, but then subsequently all the interactions and all those things that happen after it are also additional information that goes into the database, right? LinkedIn, each one of these new profiles then is, aspects of that individual's age and their career profile and, what schools they went to and so on and so forth. So data isn't sparse. There's abundant data. Sorry about that. Let's see. Let me just make sure I'm still sharing. Okay. Present this again. Okay. So, and it's another thing is, like, I like the Netflix example because all of us sort of use Netflix, but they're adding over 10 billion rows of data to multiple databases a day. And so, every click, how long you watch, how long you actually just even have an ad that exists in your view screen, for example. All of this is being recorded continuously. And so there isn't just like more of the same data. Obviously, the scale is much finer, but I think another thing that's interesting to point out is that, before an advertiser or something, they would have to go and actively solicit information about their customers. It was an intensive process. But now we just put out the data, right? Like, we post things to Facebook, we post things to Twitter, we post pictures to Instagram, all of which contain information. A picture on Instagram contains the hashtags. It contains text that you can use to gauge sentiment, or if you're excited or depressed. It contains location data, what type of phone you're using, all those sorts of things. So we're actively putting out a bunch more data, and it's now user generated. And it also then creates different types of data. So there's lots of this unstructured data. And so, like, an easy example to think of for unstructured data is text strings, right? So each tweet is an example of unstructured data, where it doesn't necessarily neatly fit into a database, but it's still really valuable because you can use it to gauge aspects of political sentiment or opinion, or, an individual's mood, which we'll learn more about. So that's why, this data, the amount of data has been increasing, exploding. And so, like, why do people just gather it up? Like, why don't companies just come along and say, well, let's not record everything? And it's just because fundamentally data is extremely valuable. So, this is an estimate of, like, big data, so how much all the data in the world is worth on a yearly basis. And so you can see, it's the data itself is worth $56 billion, or 49 right now in 2019. And because it allows companies and corporations and governments to make more specific decisions. Similarly, when you look at sort of a direct aspect of how much value this creates within a company, Amazon itself is estimated to be creating or making $2 to $4 billion just off their advertisements alone. And so we're going to take a minute to talk about sort of like how they're using this data and like why this ends up being so valuable. So talking about data mining at Amazon. So Amazon, I think it's important to think like they know so much about you. And a lot of this is voluntary information. So you go ahead and you make a profile and there's aspects of your name and gender and age and maybe some other information that you can put in there, your address, like where you live. And so a lot of this you're giving up, and that can be used, of course, because myself as a 30-something-year-old might be buying different things as another individual who's like 60 years old. So they can target ads differently. They know that we're going to buy different things. They give us different ads. But I also like to point out, because it's kind of fascinating how deeply they use this sort of in quote unquote voluntary information. So this is information that instead is sort of you're putting out there that they can then get a lot more from. So you put in vehicle information, marriage status, kids. And so, I like this example. So my wife drives a 2007 Honda Ridgeline, which is a fun little truck, but nonetheless, it's, now I'm 12 years old. And so it obviously is going to need some repairs and needs little things. And so like headlight bulbs go out or whatever. And so Amazon asks you, hey, check this product to see if it fits. And so this is really valuable because not only can they give you targeted ads based on things that they know that other individuals with a Honda Ridgeline are buying, but it also says something that's like, oh, I'm driving a 12-year-old car and I'm probably going to make different purchasing decisions, and I probably associate differently with purchasing decisions than say someone who is putting in a 2019 like Range Rover or something, right? We are probably buying different things. There's different associations. If I buy these headlight bulbs, I'm probably not buying, really fancy electronics, or really expensive furniture off Amazon, right? Because I'm driving a 12-year-old pickup truck, or well, my wife is for that matter. Same with like marriage status. So my wife and I got married recently, and so you make a wedding registry, because you want people to get you stuff, right? Free things are better than things you pay for. And so, when you make this, obviously they're getting ideas about your preference. What color towels do you like? How many wine glasses are you buying, right? Are you into fancy cookware, whatever it may be? But it's more than that, right? They know if you're about to be married, and so you probably want different ads if you're about to be married, right? Compared to if you're a newlywed and you just are married, or a year after being married, or 5 years later after being married. You're going to want different things. Individuals' needs change based on how their life changes from these major sort of life points. And like kids is another good one. So you can think of it as a baby registry, right? So if before you actually go and get pregnant, you make a registry, well, you obviously want all these things to get ready for having a new baby in the house. But you now have a birth date, right? That is inputted into this baby registry. So Amazon now knows you have a kid, and they're obviously going to want to give you different advertisements and suggest different things 1 year after the baby's born compared to say 5 years after the baby's born. And so this is kind of crazy, but like this is like a newer part of Amazon's business, but it's already estimated to be worth about $125 billion. It's worth more than IBM and all these other major corporations that are so prevalent, just because they're allowed to get so detailed. And so there's a reading that I want you to go do. And so it's because they just have this massive database about everything you buy across virtually every domain. So they know what you buy, they know who buys it, and why they buy it, and when they buy it. And they can use this and mix this with all these aspects of personal information to make these just really targeted ads. So companies can come in and they're like, I have this product, I really want to hit this demographic. And they can then just go and click a button and say, all right, show these advertisements to say people with colds or people with kids in a certain age range. My favorite specific one within there, the article is talking about is people who like Denzel Washington, right? So people are streaming a lot of Denzel Washington stuff. Well, those people are maybe of a certain age and they tend to buy certain other things. So let's go ahead and recommend this item, the product, to other people who like Denzel Washington. People who are keto dieters is another example. So there's a company who sells some cheese product and they're trying to market it to people who are on this like weird keto diet. And so individuals who had already searched for keto related products, well, of course, you just want to target those with that ad. And so this company went and did that, and it was highly successful. And so historically, you just couldn't get anywhere near this specific in how you targeted an ad. So like you can imagine, like Ellen as a TV show, just pop in my head. But she's someone who I think has like pretty broad reach. Like a lot of different types of people and different ages and incomes and demographics watch her. And so if you're an advertiser and you're trying to sell something specific, you might only be speaking to 5% of the individuals that are watching that show, which is obviously a really inefficient way to advertise a product. But by leveraging all these data mining techniques, you can start getting more specific in terms of leveraging all these big data sources of tech to be like, all right, I can predict who will like and who will buy this based on what features or what they like. So that's like a really good example of sort of how Amazon leverages data mining, digging into their data sets to make associations of products and who buys what and when and why, to then increase their ability to advertise and sell ads. I think a really another fun example in an article that I gave you is data science at Target. So fundamentally, can they predict if a woman's pregnant before she tells us, right, as us being Target? And the answer is yes, they can. And so why would they do this? Well, the article kind of gets a little bit more into the psychology and consumer psychology about how if you can hit people at certain time points of their lives, they're really willing to change brand preferences, and it's really easy to capture them as customers. And Target's like a store that has everything. And so if they can get people in there and starting to shop, well, then they can kind of retain them for a lot longer because it can be a one-stop shop for everything. And specifically when people are pregnant, they end up being really tired and they start making, they're really stressed out, so they don't want to stop as much. So if Target can figure out who's pregnant, they can, increase sales and really, really help capture customers. And so how they do this is they have these massively deep databases, right? So anytime you come into the store, go to a website or call or whatever it is, they know that you're interacting with them. And so they always have your unique ID. And so we probably all have one, and they're knowing how much we're interacting with Target as a store. They also then, I like this paragraph because it talks about that they get so much more information that if they don't have directly, they can just go buy it, right? So it can be aspects of ethnicity or job history, bankruptcy, so on and so forth. They can get massive amounts of data on you to then make predictions about who's buying what, how should we advertise to them, what ads should we email to them, what sale links, so on and so forth. And so, then they came to him and they're like, all right, in terms of predicting if someone's pregnant before, what they instead did is they went and looked at, well, we know we have a registry. And so we have these IDs of women who are on the registry. Let's see what else they were buying. Let's see the history of what they were buying. And what they found is that they're buying larger quantities, for example, of unscented lotion around the second trimester. So when women start getting more sensitive to smells, they don't want the smells of these lotions. And so that's this thing that, hey, all these women that are on the registry, compared to other women who are not on the registry, they're buying more of this certain product. And they identified a number of these other things, right? So supplements, starts buying more of the scent-free soap or lots of cotton balls. You want to be clean, so you have a lot of hand sanitizer, washcloths. You have this now trend and profile of what happens when women are pregnant. What do they buy and what do they buy over time? And so as a result, if you now have a list of a bunch of women who are not on the registry and you see, hey, they started buying this sequence of products that seems to be correlated with pregnancy, you can probably predict they're pregnant, which is what they did. They were able to identify about 25 products to create a pregnancy score with. And so, this is obviously a potentially creepy thing, or at least back then it was much more creepy. And so Target actually is kind of funny, talks about how, before they would send ads directly about being pregnant, and then they had to back off that because women were just kind of getting sketched out in terms of like, how does Target actually know this sort of stuff? And so they started just being more discreet about it. So what they would do is they're like, well, we know these women are pregnant, so let's send them an ad for several things, and in there will be a pregnancy ad, or something related to pregnancy. I think what's kind of funny is nowadays we're almost somewhat used to this. All of us sort of like joke about how you talk about something and I'll see an Instagram ad about that thing you're talking to despite never searching for it or whatever. So we're all like, ooh, that's creepy. And then we put our phones back in our pockets and sort of keep talking about it. So we now kind of, I think, are more used to the fact that these things are being done. But obviously it's very important for companies and they can use it to make a lot of money. I want to say that data mining can figure out more than like just what we want to buy. It's easy to focus on that because that's sort of, where it's really exploding, but they can create a lot of other information, right? So you can get this solicited information. So, you know, you have Amazon to where you're volunteering aspects of your life, you're saying what kind of car you have, all this sort of stuff. But sort of the study in 2012 was fascinating, that what it was able to do is take groups of people that put out their age and gender and openness, but what it did was it ignored those. And it's like, well, what do these people like and click on of terms of different political affiliation or types of ads? What kind of stuff do they interact with? And then can they predict gender and age and openness? And what you found is that yes, they very much can, right? So they can really highly accurately predict aspects of gender and age, but they can also predict psychological traits to the same accuracy as a trained psychologist. And so that's pretty amazing that, you know, you can get so many aspects of an individual's political leanings and, you know, psychological leanings and so on and so forth, and use this to not only advertise, but say then political ads, right? Like you would target differently to someone who's, say, maybe open of a certain age and gender than someone who's not, or the opposite traits. So scary, and sort of, I think, like, this important thing to realize is that they can get a lot more than just information. They can get a lot of inference from what information you put out there. So I'm just now going to have a couple of slides here on different tasks and methods like that we're going to be using in these class. And so data science, data mining, this is, you know, a booming field. The methods are evolving really rapidly, and so the focus of this class is to really just give you a good core, right, of these prominent methods that then are normally the basis of a lot of other things. And so we'll learn more about these as class progresses, but I want to talk about some of the main ways that individuals would apply a model to make some inference from these big data sets. And you can kind of divide it into like three, I think, main tasks. So you have like regression. And so you can imagine that you have like a house price based on different factors. So regression tends to be, when you think about like regression problems, are when you have a continuous variable. So a house price is something, you know, where it could be $20,000, say, in some area. I'm sure there's houses that are very cheap, all the way up to, you know, $20 billion. And then there's a big range in there with a mean and a median and some distribution about that. And so you can predict the actual dollar value based on a bunch of different features. So how big is it? How many square feet? Beds and bathrooms? Is it a pool? What zip code? All these different things. And so methods, you know, linear regression, which is something we are going to learn more about. You all have probably taken a stats class or had to have taken a stats class. But so we're going to dig more into linear regression. We're also going to get into other methods, so decision trees and forests, neural networks. We won't be doing neural nets in this class, but these are methods that you can use to do regression problems. They can be leveraged to do those. Classification then is now, instead of a continuous thing, you have, say a binary thing. So you want to predict, does a user click an ad, or does a user purchase something, yes or no? And then this is, you can extend linear regression from a continuous to being a binary, and then it becomes logistic regression. So you predict a 0-1. There's also other non-statistical algorithms out there, so like k-nearest neighbors, for example. You can still use decision trees and forests, support vector machines. So there's a bunch of these different models that you can use to apply to make these classifications. And then clustering and association. So, you know, you have groups of people that are out there, or groups of products or events or whatever, and like, how do they lump together? Like, do you see these clusters and these associations forming, and what's underlying that, and what do those clusters then do? And so some of the methods there, say, for example, like k-means and density-based scanning is sort of an example, a couple examples. And there's tons and tons of clustering algorithms. We're not going to learn them all, obviously, but we're going to learn a couple. And with all these, we're going to kind of learn the pros and cons to each. You're going to learn how to sort of like test, well, when would you apply one, when you apply the other, where does it fail, where does it not? And additional correlational methods. So tasks and methods, I think it's important to say that although these methods are all great, there's obviously a lot more than just applying a model, right? So like, to apply a support vector machine for classification, it's just like SVM, and then you tell it what data you want to use. In R, it's a single line. But of course, that's dangerous. You know, if one thing, it's like one thing if you have an exam or you have a project for class that you're going to go and apply a model for. If it's not going to fit well, you lose a few points. But if you're working for a company that's making decisions about tens of thousands to hundreds of thousands of dollars advertising budgets, and you're applying models and using the inference to tell them how to make those decisions, you need to make sure this is right. And so there's a lot more than just telling R or Python or whatever to fit a model. Instead, there's actually really a lot about how to make sure you're fitting it correctly and can assess it. And so I think it kind of gets divided into a couple things. So like pre-processing is a really big one. Data is often really dirty and needs to be cleaned, right? So it has errors. We're not going to do too much in that class, in this class, but it's a really important step. Data may exist across multiple databases, so you might need to sort of aggregate data in order to actually answer your question. Data might contain like the specific feature you need, so you might need to manipulate columns to create a new one that's sort of more informative. Data also may, say, contain too many variables. This is a big problem. You have these, massive amounts of data generation. Let's just say, if you can think about every variable of a house, so, square foot and bathrooms and pool, number of floors, these are all easy ones to think of, but you can start imagining every detail of a house, number of outlets, what type of flooring does it have, how much carpet does it have, every little thing you could imagine could become a variable. And some may be useful and some may not. And what do you do when you have too many? How do you make sure that you're asking your question efficiently? And that is something we'll definitely be spending time on. And then ensuring a quality fit. So part of this is making sure that when you fit your models, you're doing these different subsetting methods to fit and then refit to different sets of data to make sure that things are actually accurate and your model's useful. And then also looking at multiple aspects of fit quality. So we've taken stats classes, and so you know about things like a p-value and r-squared, and these are interacting and important. But there's also things you can look at, such as like bias, variance, trade-off, and area under the curve. And so we're going to be understanding and looking at those methods and using those to assess, well, when is a model good and when's not, and what do you do in those cases? So this is about, learning a whole data science pipeline, a data mining pipeline that you will then be able to go and use and take out into the working world. So thanks for taking the time to listen. If you have any questions or anything, please post them up to the Slack. If you have any comments on the video, please also post to the Slack. I'm always eager to improve the quality or provide more information. Thanks for listening.